Hello viewers, I am Hansi from Natural Nerd, and today we'll be covering the super relevant topic of how to turn on and off lights wirelessly. Ever since 2014, the microcontroller ESP8266 has made wireless control a lot more accessible. Since then there has been a bunch of improvements and new releases of the controller, but in this video we'll be using the 12S version on a WeMOS development board. WeMOS creates other modules that stack on top of the Wi-Fi chip. For this purpose we will take a relay shield and put it on top of the Wi-Fi board. A relay works like a switch in a circuit, and this one can be controlled by the Wi-Fi board. When we put them on top of each other, they can communicate without any extra wiring. To see that everything works, the relay will be connected to a 12V LED strip with a set of jumper cables attached to it. Normally, an LED strip is wired just like you can see here, which makes the LED strip give off a constant light. When we wire it through a relay, the relay controls when the circuit is open and when it is closed. So how exactly can we tell a relay how to act? Well, it turns out we can connect the relay to an Arduino, or in our case a WeMOS board. When they are stacked on top of each other, the WeMOS board controls the relay with digital pin number 1. So when the pin is set to high, the circuit is closed, and when it's set to low, it's open. The WeMOS itself can be powered with a 5V power source or a simple USB cable. Now that we have set everything up, we can dive into the code that's needed for this to work wirelessly. So in our Arduino software we have to first install the ESP8266 board. And that can be done by first going to File, then Preferences, then we're gonna type in an URL. URL is http:// and then arduino.esp8266.com/table/package_ESP8266com_index.json. And when you check that the link is correct, press OK. Then you can go to Tools, Boards, Board Manager, and then type in the search ESP8266. And then we get the ESP8266 by the ESP8266 community, which we can install, the latest version, and then we're just waiting for that to install. The next thing we're going to do is install the ESP8266 library by going to Sketch, Include Library, then Manage Libraries, and install the Adafruit 8266 library. Having that done, we can include the library and then compile the code to check that it works. Make sure to select the node MCU1 as the board to compile to. There's gonna be 3 main parts to the code. First part is connecting to the local Wi-Fi, the second is creating a server, and the third and final one is turn the relay on and off based on the input from the server. Beginning with the first part, we create 2 constants to hold the credentials to our Wi-Fi network. In the setup function, we tell the board to attempt joining the local network with the credentials we just typed. While it's still attempting to create a connection, we tell it to print a dot to the serial output every half second, just to see that something happens. When it is connected, we can print out the IP address so that we can connect to it later. So now that the board is connected to the Wi-Fi, let's code the second part, creating a server. First we specify a port number in a constant. I chose 8181, but you could mostly choose whatever you like. And then we tell it to use that port as the server port. Now in the loop function, we create a client variable that fetches the available clients. If there exists a client that is connected, we check whether that client has any available data sent to us. The next part is a little trickier. For this example, we're going to assume a client only sends 1 byte of data at a time. That can of course be changed later. We create a variable for this byte and we call it buff. Then we instruct the program to read 1 byte of the available data into buff. When that is done, we call the function handle command that we will create later, and then write the return value of that function call back to the client. When this is done, we can close the connection by calling the stop function. Now we need to perform an action based on what we got from buff. Handle command takes a command parameter and then checks if the value matches the ASCII value of 1 or the ASCII value of 0. If it does, it returns a message that the digital pin value was changed. If neither 1 nor 0 was provided, a return message that informs about the available commands is returned instead. You may have noticed that we haven't actually done any physical changes based on the input from the command, so the last part is naturally setting the value of the digital pin. And this value is changed only within the switch statement in the handle command function. When 1 is received, the light turns on, and when 0 is received, the light turns off again. Now the question is, how do we actually send 1 and 0 to the server? Turns out this is a regular TCP connection, so we can just open Telnet or any tool that lets you open a TCP connection and then type in the value 1 to turn the lights on. If you use a Mac, you can use netcat with the command nc or use telnet there as well. If you're unsure about the IP address of your ESP module, you can check your router configuration, or you can simply open the serial monitor in the Arduino software and you will see the outputted IP address there. So this is extremely useful because now it is very simple to write a second module that only sends single bytes to this module in order to invoke changes in the environment, like turning your lights on. And if one wants to look fancy, you could control the lights with a terminal. This video was sponsored by our Patreons. If you like our content, please consider pledging $1 on Patreon to help us create a sustainable future for Natural Nerd.